Thank you very much. Today, I would like to talk about CRDT and how to build a rich text sync model with Core Data and CloudKit. Before we dive in, just a quick intro. I'm an iOS and Mac developer, and I run a small app development company. We have 3 productivity apps on the App Store: Calendar, Tasks, and Notes app. These apps sync their data via the cloud, and I've spent quite some time dealing with syncing issues and data conflicts. And that's what led me to CRDT. So let's get started. Imagine this. You're on a train editing a meeting note on your iPhone. You go into a tunnel, so there's no signal. Meanwhile, your coworker opens the same note on her Mac and edited the note. A few minutes later, you come out of the tunnel, your phone reconnects, and to your surprise, what you wrote is gone. What happened? Well, maybe this app was storing the note in a database like this. There's a note table, which has a field called content, which stores the string of your note. Now, in a data structure like this, you can only store one version of your note. So if you and your coworker edits the same note at the same time, you have 2 versions of your note, but there's only one field to store it, so one data will override the other. So the truth is, merging is hard, because most data models aren't designed for merging. In most data models, changes are stored as final states. So conflicts become destructive. Data is overwritten. So without the right architecture, correct merging is impossible. And that's where CRDT comes in. It stands for conflict-free replicated data types, and it is a data structure designed to be mergeable. With CRDT, every change is preserved. Nothing gets overwritten. So there's no conflict, there's no manual resolution. And CRDT is not just for text, because Figma uses CRDT for real-time collaboration. You may have seen this article where Figma talks about how multiple users can edit the same canvas at the same time thanks to their implementation of CRDT. So when we were building a note-taking app, we decided to adopt CRDT from the start. This app is called First Seed Notes. It is a rich text editor that runs on iPhone, iPad, and Mac. This is a Mac version, which, by the way, is built using AppKit. And as you can see, this app supports rich text, such as headings, checklists, code blocks, etc. You can even type in Markdown. And today, I would like to show you how we built CRDT into this app using Core Data and CloudKit. Let's start with a basic idea of CRDT in the context of handling text, which is that you should not store strings as it is, but rather you should store identities, relationships, and states. Let me explain this. If you want to store the word hello, for example, you don't store it in a string in a database, because that's not mergeable. Instead, you store each character separately. For each character, you assign an ID and store it. And this ID must remain constant for the lifetime of the note. Each character has also a relationship to the previous character. So previous ID is stored for each character. And each character should also have a timestamp. This can be a logical timestamp, a server timestamp, or maybe even a local timestamp under certain conditions. And really, that's all you need to make this data mergeable. So let's look at an example. Suppose you have the same note on an iPhone and a Mac. They both have the same content, which is ABC in this case. Suppose you edit the note on your Mac, on your iPhone, by adding 1 after the letter A. And around the same time, someone else edited the same note on the Mac by adding 2 after the letter B. So how should we merge this? Well, since we're using CRDT, the internal representation actually looks like this, where each character is stored separately with unique ID and relationship. So when you insert 1 after the letter A, you're simply creating a new character that points to A. So now 1 and B both points to the same character. In this case, you compare the timestamp of these characters, and whatever that was typed later should come first in the ordering. So this data representation at the top right will translate to A1BC. Similarly, if you look at the internal representation on the Mac, it looks like this. 2 was inserted after B, so you create a new character that points to B. And since C and 2 both points to B, but since 2 was typed later, 2 come first in the ordering, so you would get AB to C. And now it's really easy to merge these changes. If the iPhone sends 1 to the Mac, and the Mac sends 2 to the iPhone, both devices end up with the exact same state in a tree structure like this. Because with this data model, there's no point of failure. There's nowhere that will cause any of the data to be overwritten. And that's why CRDT is mergeable, because you're adding to the data, so nothing gets lost. Another great thing about CRDT is that you can merge these changes regardless of the order of the changes that come in. So for example, if there's a third device, say an iPad, and if the iPad gets the change from the iPhone first or the Mac first, it doesn't really matter, because by the time it gets both changes, it will end up with the exact same state as other devices. Now, you might say, what happens if you delete a character, right? Let's suppose that the user deleted the character B. In CRDT, a deletion will simply create what's called a tombstone. The element is marked as deleted, but it will remain in the data representation. So all of the relationships will remain valid, nothing gets broken. And this is how CRDT works. So we wanted to incorporate CRDT into our note-taking app. And we decided to use Core Data as our local storage and CloudKit as our backend. Why did we make that choice? Let me talk about Core Data. First, it's a first-party solution, so no third-party libraries are required. Core Data is also highly scalable. It can scale to millions of records. Core Data is also very highly performant, with features like faulting and dictionary result type. Core Data also supports concurrent writes, meaning you can write your data on the main context as well as the background context. And this is important because you can save user edit on the main context while handling background sync at the same time. Core Data is also crash safe and preserves database integrity using various mechanisms such as write-ahead logging. Now let's talk about CloudKit. Again, we chose CloudKit because it's a first-party solution. But privacy is perhaps the biggest reason. Since we're building a note-taking app, the content could be very private, and we wanted to make sure your data stays private. For users, there's no sign-in or sign-up process. For us, there is no server management. And CloudKit also has a built-in support for sharing data with other iCloud users. This lets us build features like sharing a note with your family or team members. And all of this is free to developers, as long as you're using private and shared databases, which we are, so this is great. So now, let's implement CRDT using Core Data. You create a note table, which stores the list of your notes. And then you create a CRDT entity table, which has the ID, previous ID, content, timestamp, and a deletion flag. All of the properties we need to make the data mergeable. And Note has one-to-many relationship to CRDT entity. Now, with this data structure, we can already create a plain text editor that supports CRDT. But we want to handle rich text. So how can we extend this model? Let's consider adding an image support. When you think about it, an image isn't fundamentally different from a character. It still needs an ID, a reference to the previous entity, a timestamp, and a deletion flag, so it can exist anywhere in the text. At the same time, it needs image-specific properties like a URL, width, and height. So we model this using abstract entity. An abstract entity works just like class inheritance. So you define a base class, base entity, and extend it with additional properties. So in this case, we created a CRDT image entity that extends CRDT entity and added the field needed for images. And with that, we get image support. We also wanted to support text styles, such as bold, italic, strike-through. So we created CRDT character entity and added a style property where int32 maps to an enum representing text styling. And that's it. We now have styled text support. Adding support for checkboxes and lists required a bit more work. We realized that checkboxes, ordered list, and unordered list all share common behaviors, such as indentation. So we introduced CRDT list as an abstract entity. From there, we create CRDT checkbox for to-dos, as well as ordered and unordered list entities for numbered and bullet lists. We also added support for headers, code blocks, and block codes. And both code blocks and block codes don't have additional properties, as they essentially act as marker entities. So that covers the data structure. Now let's look at the algorithm that is used to load this data. First, we use NSFetchRequest to fetch CRDT entities that belong to a node. And the key here is that we don't load NSManaged object directly. Instead, we fetch the data as dictionaries. And this can be done by setting the result type to dictionary result type. Because if a node contains 10,000 entities, for example, loading 10,000 NSManaged object will affect memory and performance. While NSManaged object comes with a lot of useful features, it also comes with overhead. So that's why we use dictionary result type in order to reduce the overhead. And this is actually one of the reasons why we chose Core Data over Swift Data, because Swift Data does not support this feature. So now that we have all of the CRDT entities for a node, we use this algorithm to build a tree structure of the CRDT nodes based on their previous entity IDs. In other words, we construct a tree where each node is connected by the previous entity ID, like the tree you saw in the earlier slide. We then use an algorithm like this, which takes that tree structure and traverse it to make a sequence of nodes in the exact order that the user should see. So we start from the root, and we walk through the graph and recreate what the user typed. So With these data structures and these algorithms, you should be able to create a rich text editor like this that is fully backed by CRDT. Of course, we've done a lot of work using TextKit 2 to display these CRDT entities. But this is only half of the story, because you would have to sync this data using CloudKit. So let's talk about that. Now, it is important to understand that CloudKit has several limitations that do not exist in Core Data. Apple developer website covers some of the basic limitations, such as unique constraint not being supported, all relationships needing to be optional, and ordered relationships not being supported. But CloudKit has additional limitations, and the one that will affect our database design is the number of records. I don't think there's any hard limit on the number of records in CloudKit, but from my experience, including WWDC labs, syncing a large number of records is likely to cause performance issues. With the current design, if you have a node with 10,000 entities, for example, you will end up with 10,000 records in Core Data. And while Core Data is more than capable of handling that, CloudKit is not. Delta syncing 10,000 entities via CloudKit will take a considerable amount of time. There's another thing we need to consider, which is sharing. One of the challenges of using CloudKit is that syncing and sharing are two separate things. Just because your data model can sync doesn't mean it can be shared. To make your data model shareable, you have to have proper parent-child relationships between your records. So here's what we did. Instead of Node having CRDT entities, we broke the link between these two records, and we added Node ID and segment in CRDT entity. And then we created node data and established a link between these two. Node data has asset data, which can contain the binary data of up to 3,000 CRDT entities. If a node has more than 3,000 entities, then it will create another node data with a new segment. And with this structure, we can sync with CloudKit. And the data is also shareable with CloudKit because the child-parent relationship is established between node and CRDT entities without having too many records. So let's see all of this in action. This is first seed node running on a Mac. And let's create a new node. Suppose you type some text on the Mac. And let's say you added some text on your iPhone. When the app syncs, the change appears highlighted in yellow like this. You can highlight changes in multiple places, like that. And you can highlight images as well, although that may be a little bit hard to see. Now, the reason we can do all this highlighting is that in CRDT, each character has its own ID, so you know exactly what has changed. Let's look at another example. This is a feature we built as an experiment to demonstrate the power of CRDT. You can build a time machine-like feature that lets you go back in time as you move the slider and view your node's history. This can be useful when you want to see a previous version of your node to recover some text that you might have deleted already. And CRDT makes this possible because each character has a timestamp. So you know the exact order in which these characters were typed. So to wrap up, CRDT is a very powerful concept. It's not just for syncing text. It can enable features you may not have thought about before. It also goes beyond text. The same idea can be applied to many types of data, not just characters, but images and other structures as well. CRDT is also highly adaptable. You don't have to follow the textbook definition exactly. Even companies like Figma take the core idea and shape it to fit their need. And honestly, what I show today may not be a pure CRDT implementation. It's adapted to my use case, but it works great. Finally, the academic side of CRDT is much deeper. There's a lot more theory and much broader applications. So if this topic interests you, I would definitely encourage you to explore it further. With that, thank you very much.